Ever imagine a particle existing in two places at once? Or that observing something changes its very reality? Welcome to the bizarre world of quantum mechanics. Quantum mechanics describes nature at its smallest scales, governing atoms and particles. It's famously counterintuitive. Today, we explore why it's so weird. First, superposition. A quantum particle exists in multiple states simultaneously until measured. Imagine a spinning coin, neither heads nor tails until it lands. Electrons can be up and down, or here and there at once, collapsing into one state only when observed. Next, entanglement, which Einstein called spooky action at a distance. When two particles entangle, they're linked regardless of separation. Measure one's property, and you instantly know the other's, no matter the distance. No faster than light communication, yet they seem to know each other's state. Finally, wave-particle duality and the uncertainty principle. Subatomic particles don't just behave like tiny balls, they also act like waves. Heisenberg's uncertainty principle states you can't precisely know both a particle's position and its momentum simultaneously. Measure one more accurately, and you know the other less, a fundamental limit. From superposition to entanglement and duality, quantum mechanics forces us to confront a reality far stranger than our everyday experience. It challenges our notion of what's real, showing the universe operates on truly bizarre rules. If you found quantum weirdness fascinating, hit that like button, share your thoughts, and subscribe for more scientific deep dives.